Hello everyone, welcome to my YouTube channel Know About Embedded System. So in today's video we will understand one of the important topic that is called as a differential voltage, which we will be using in our CAN protocol. So with the help of this differential voltage we are able to transmit our bits, zeros and ones to the CAN bus. So without further delay, let us start the video. But before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. So guys, you all know that already we will be using ECUs in our automotive system. ECUs are nothing but our nodes. The currently whatever you're seeing, each node represent one ECU. In this ECU, we will have different components that we have already discussed in the previous video. So most importantly, we'll have a host microcontroller, CAN controller, CAN transceiver, and CAN bus. So whenever you want to transmit any data from host microcontroller, so nothing but our bits, number of bits, whatever will have number of bits, those number of bits will be given from host microcontroller to CAN controller, and from CAN controller to it is going to be connected to CAN transceiver, and the CAN transceiver will convert your bits, whatever you're giving the bits, those bits the CAN transceiver will convert into differential voltage, and that differential voltage signals will be given into the CANH and CANL, nothing but our CAN bus. So we know that CAN bus is having a CANH and CANL, and CAN transceiver is responsible for converting your bits into differential voltage values, and it will be connected and it will be given to the CAN bus for broadcasting. So what is this differential voltage that we will see now? So guys, differential voltage, this is one of the important thing in our CAN. What is the differential voltage? Now let us understand. So when I say differential voltage, it is used to represent our logic levels. In our embedded system, we have a recessive logic and dominant logic. Recessive logic means logical 1, and the dominant logic means it's logical 0. To represent zeros and ones, we are going to use a differential voltage in our CAN protocol. In our CAN protocol, you know that already we have in our CAN we have two lines, nothing but two wires. One is a CANH and one is CANL. Now when you observe very clearly here, whenever you want to represent a recessive logic means logic 1. Here you observe here the both CANH and CANL are staying at common voltage level, that is at 2.5 volts. You can observe here CANH and CANL both are staying at, or they are maintaining the voltage level of 2.5 volts to represent logical 1. This is the one case. One more case, if we consider our logical 0, nothing but dominant bit, CANH, you see where it is holding the voltage value. CANH is holding the voltage value of 3.5 and CANL is holding the voltage value of 1.5. Now we are going to consider the difference between these two. This is called as differential voltage. To represent logical ones and zeros in our CAN bus, we are going to use a technique called as differential voltage technique, and with the help of differential voltage techniques we are able to represent each bit in a three different voltage level. Logic 1 is represented by 2.5 and 2.5, and logic 0 is represented by 3.5 and 1.5, and we will consider the difference between these two lines, voltage lines, to understand the bit level, whether the bit is 0 or 1. So now how in a mathematical way we can represent like this. Differential voltage in our CAN protocol is defined in this way: the difference between CANH and CANL voltage, CANH minus CANL. To represent a logical 1, we have to consider the difference between CANH and CANL. Both are staying at 2.5. 2.5 minus 2.5 is equal to 0 volt. Similar to that, to represent a dominant level, nothing but a dominant logic level, logic 0 is equal to CANH is 3.5 and CANL is 1.5. The difference voltage is 2 volts. So in this way, we are able to consider the difference between two different lines, or two different CANH and CANL, to represent logical zeros and logical ones. This is done by, this complete process will be taken care by our CAN transceiver part, which we have seen in the previous slide. I hope this is clear. And how this differential voltage is represented in a canvas, continuously when you're transmitting, this is how it is going to be represented. You can see here, this is a logical one. The two lines CANH and CANL are staying at 1, then 0, 3.5, 1.5, 1, and it goes on like that. So in a millisecond and in a microsecond, the switching will happen between CANH and CANL. So this is a differential voltage with respect to CAN. So I hope this video is clear to all. If you feel this video is an informative video, please click on the like button and subscribe my YouTube channel.